Hi and welcome to this, the third of my videos on drawing Lewis diagrams. And today I'm going to show you how to draw Lewis diagrams of ions, which is very similar to drawing Lewis diagrams of atoms, just one little tweak. Okay, so the key thing to remember with an ion is that anions have gained electrons and cations have lost electrons. So you need to add or subtract the number of electrons gained or lost to the total number of valence electrons. So you include those in the total. Then you draw your Lewis diagram as normal. And then to finish off, you draw your ion in square brackets with the charge showing. Now, that doesn't necessarily make a lot of sense until you've seen it. But other than that, we're going to follow the same general rules that we always do for Lewis diagrams. So, start off by counting the valence electrons. So we're going to do, first off, a fairly simple ion, and I'm just going to do ammonium. Now, this is where the lack of subscripts and superscripts is quite annoying, but of course the 4 is a subscript and the plus is a superscript. So it's 1 nitrogen, 4 hydrogens, 1 positive charge. So we're going to count up our valence electrons first off. So nitrogen has 5 valence electrons. Hydrogen has 1 valence electron. We've got 4 of them. So that's going to give us a total of 4 valence electrons in our molecule. And our positive charge means that we have lost 1 electron, and this is a bit that trips people up. So because it's a positive charge, we've lost an electron. So we're going to subtract 1 electron off our total. Therefore, our total is still going to be 8 valence electrons. Okay, 8. So 5 plus 4 is 9, minus 1 is 8. So keeping that in mind, we're going to do the same trick that we always do. So we're going to start off by laying out our atoms, and we are going to lay these out with the nitrogen in the middle, because hydrogen can only have a maximum of 2 electrons, so it can't be in the middle. So we've got hydrogens, nitrogen, hydrogen, and then we've got 2 more hydrogens, hydrogen. Okay, now this is quite simple, so I'm not going to step it through bit by bit. I'm just going to talk you through as we go. So the next step that we're going to do is we're going to put a bond between each pair of atoms. So we've got 1, 2, 3, 4. That is 2 electrons in each bond, which is 8 electrons. With 8 electrons in there, which is the total number of valence electrons we had, that Lewis diagram is all done except for one thing. We need to put it in square brackets with the charge showing, like so. And that is the Lewis diagram for ammonium ion. Okay, so let's have a look at something a little bit more complicated. Here I would like to show you the Lewis diagram for the triiodide ion. Okay, that is I3 minus 3 iodines and 1 negative charge. Okay, so how are we going to do this? Well, we'll start off counting the valence electrons, same as normal. Iodine has 7 valence electrons. There are 3 of them, which gives us 21. There is a negative charge there. A negative charge means it has gained 1 electron. So we're going to add 1 electron on. So our total is going to be 22 valence electrons. That's what we've got to do. Now, the next thing that you might be asking yourself is, how the heck do I lay this out? Well, let's have a quick look. We're going to just lay them out in a line. 1 iodine, 2 iodines, 3 iodines. Because all three atoms are identical, then they should all have the same number of valence electrons. They've all got the same electronegativity, so we're just going to assume they connect one to the next to the next. And in the absence of any further information, that's all we can assume. Okay, so let's look at where we put the electrons on this. Okay, I'm going to start off, just as we always do, with some bonds. Okay, one bond here and one bond here. Now we started off with 22 valence electrons. We've put in 2 bonds with 2 electrons each, so that's 4, which means we have 18 valence electrons left. So we're going to start off by filling in those surrounding atoms, just like we always do. 8 electrons around those surrounding atoms. So we've got 2 in the bond, 4, 5, 6, 7, 8. Okay, pretty ugly, but you know, 2, 3, 4, 5, 6. Now, here we get something slightly tricky, which is why I wanted to use this as an example. So we've now drawn in our valence electrons. How many valence electrons did we put in? Well, we've drawn 12, which means we have 6 valence electrons left. Where are we going to put those valence electrons? Well, there's only one place that we can put them. They've got to go on the central atom. So 6 valence electrons, 3 pairs, 1, 2, 3, 4, 5, 6. Final step, so that's all our electrons counted for. We do still have to put it in square brackets. With the charge, showing us a superscript up to the right. If you don't put it in square brackets and you don't put that charge on there, it is not correct. Okay? I've marked a lot of papers where I've seen students draw a really good Lewis diagram, leave the square brackets and the charge off, and they don't get marked right. Okay? Please, please, please put the square brackets and the charge on for any ion. Okay, so that is how you draw Lewis diagrams for ions, and that includes ions with extended octets around the central atom. Join me in my next lot of videos where I'm going to start talking about shape of molecules. See you there.